Okay, you guys, so now we're going to actually use all that factoring we've learned to solve some quadratics. So remember, we move all the terms to one side and set the equation equal to 0. Then we factor, and we set each factor equal to 0 and then solve for each x value. And then for your x values, we have to make sure we write it as a solution set, like x equals, and then however many solutions. So let's do a couple of these just to kind of bring us back. So the first one is one that I could factor out in x, and then I'm left with x plus 9. So then from here, what I like to do is I do x equals 0, and then x plus 9 equals 0, and I'm just solving for x. So this one's already solved, and the other one's negative 9. So then let's make sure we write our solution correctly. So it's x equals 0, 9. Let's skip down to number 3. This one's the perfect squares, so it's going to be x plus 2, x minus 2. Then I'm going to set them both equal to 0. And I'm just going to solve each. So I'm going to subtract 2. I'm going to add 2. So I get x equals negative 2, x equals positive 2, and I'm going to write it as a solution set. So x equals negative 2, 2. And you usually want to write it from like the smallest to the largest number. So let's look at number 5. Okay, this is something I want to kind of break this up. So let's think of all the things that multiply to 21, and automatically I think of 3 and 7. And you know what? Both of them have to be negative. So x minus 3, x minus 7. And now I'm going to set them both equal to 0. So x minus 3 equals 0. X minus 7 equals 0. Add 3. So x equals 3, add 7, x equals 7. So if I'm to write this as a solution set, I get x equals, I use my bracket, 3, 7. Ooh, I love number 7. This is that new method where we take the 3 and we multiply it to the negative 30. So now it becomes x squared minus 13x. So 3 times negative 30 is negative 90. I know 18 and 5 goes into 90, and 9 and 10. So hold on. 9, 10, 18, 5, 3, 30. We need it to equal negative 13, so it's going to be x minus 18, x plus 5. Remember, because we multiplied the 3 to the 30, we need to divide these by 3. So the first one should be x minus 6. The second one, remember, when it doesn't divide, it just goes to the front, plus 5. And now we have to set these equal to 0. So x minus 6 equals 0. So I'm going to add 6 to both sides. I get x equals 6. Hold on. Okay, so then now we have to do the same thing to the 3x plus 5 equals 0. So I'm going to subtract 5. I get negative 5 equals 3x. Now I got to divide by 3. So I get x equals negative 5/3. So those are my two x's. Let's write it as a solution. And I got x is negative 5/3 and positive 6. I say let's do a couple more. So let's look at the back. Number 9, I notice it's not equal to 0. So I'm going to subtract 5x over. And when I do that, now I have 2x squared minus 5x equals 0. I could just take an x out. And now I have 2x minus 5 equals 0. And I can set both of them equal to 0. So x equals 0 and 2x minus 5 equals 0. So I could add 5 to both sides. I get 5 equals 2x. We're going to divide by 2. So I get x equals, is that 5 over 2. So my solutions here are 0 and 5 over 2. So for this one, okay, so we need to move this guy over here. So I'm going to do minus x squared, and I'm going to add 1. So now I have x squared minus 49 equals 0, which those are my perfect squares, so it's going to be x minus 7, x plus 7. So I'm just going to set them equal to 0. So x minus 7 equals 0. X plus 7 equals 0. So x equals 7. X equals negative 7. So when we write that into our ordered pair, it's negative 7, comma 7. This one's a nice easy one. We just got to subtract 80 over. So x squared plus 2x minus 80 equals 0. We need to get a 2, and look, 8 and 10 multiplied to 80 and could give me that 2. So it's going to be x plus 10, x minus 8 equals 0. So then x plus 10 equals 0, x minus 8 equals 0. So this is x equals negative 10. X equals positive 8, and let's write that as a solution set, negative 10, comma 8. I'm actually kind of having fun with this, so let's keep going. Let's do 15 together. I'm going to subtract negative x squared, and I'm going to add an x. So that's going on this side, so now I'm left with x squared minus 8x minus 65. 65 I know is 5 and 13, and you know what? Negative 5 and negative 13. So it would be negative 13, right? Because we want that. So x plus 5. Because, right, those add up to the negative 8, but they multiply to 65. So then x equals positive 13, x equals negative 5. So x equals negative 5, comma 13. Number 17 is a nice tricky one. So let me do that one. I need to subtract the x over and subtract the 21 over. So it's really 2x squared minus x minus 21. This, I can't divide anything out, so we're going to do that trick where I'm going to multiply the 2 down, so it becomes x squared minus x, and then it's going to become negative 42. And from that negative 42, I know there's a 6 and a 7. Let's make the 7 negative so I could get my negative 1. So x plus 6, x minus 7. We do have to divide by 2, because remember we multiplied that at the end. 6 divided by 2, so this is x plus 3. This one, remember, bring it to the front, 2x, and then leave it as minus 7. If I set that equal to 0, I know x equals negative 3. And for this one, let's just do the math. I'm going to add 7, divide by 2. X equals 7 over 2. Or we could just write it as a solution set. I'm just going to do it right down here. So first would be the negative 3, then the 7 over 2.